All right, let's talk about the massive Cloudflare outage that recently took huge parts of the internet offline. We're going to break down what happened.
You probably saw the headlines, right? A lot of people were pointing fingers, saying the programming language Rust was to blame. But the real story is, well, it's a lot more interesting. It's a fascinating look into how these incredibly complex systems are designed, and more importantly, how they can fail. So let's get into what actually went down.
Okay, so first things first, before we can get into the nitty-gritty of the failure, you kind of have to understand what Cloudflare even does. And you got to understand, for a huge chunk of the internet, they're basically the digital gatekeeper. At its heart, Cloudflare is what's called a reverse proxy. Now, that's just a fancy term, but think of it this way. It's like an internet traffic cop. It stands between you and the website you're trying to visit, managing and directing all the incoming traffic.
So here's how that journey looks. When you try to visit a site, your request doesn't go straight there. Nope. As step 1 shows, it hits Cloudflare first. Then Cloudflare does its thing. It runs a bunch of security checks, serves you the page from its own super fast cache if it can, or goes and gets it from the original server if it has to. The whole point is to make the experience faster and safer for everybody. Okay, so now that we've got the basics down, let's zoom in on the specific service that really caused all the trouble, something called bot management. The bot management service is pretty clever. It uses a statistical model built on about 60 different features to figure out if you're a human or just some malicious bot. And you can think of these features as just different clues, right? Like what browser are you using? How's your mouse moving around the screen? That kind of thing.
But, and this is key, these features aren't just set in stone. The whole system is super dynamic. They're constantly getting refreshed, something like every 5 minutes, to stay ahead of all the new threats that are always popping up online.
And then it happened. Something went wrong. A new set of what are called feature flags, which are basically just on-off switches for code, got pushed out. And instead of the normal 60-ish features, the system was suddenly hit with over 200, a total flood. Which, wait a minute, why would more features cause a complete crash? That sounds totally backwards, right? Well, the answer is actually fascinating. It all comes down to a critical design choice Cloudflare made, all in the name of speed. So the system uses this technique called pre-allocation. The best way to think about it is like packing your lunch before a big road trip. Instead of having to stop to find food later, you have everything you need right from the get-go. It makes the trip way faster, way more predictable. And for a service like Cloudflare, where every single microsecond counts, that's everything. And this isn't some random idea. This focus on predictability is so serious, the source we're looking at points out that it's just like the rules NASA uses for its most critical software. You know, the kind of stuff where failure is absolutely not an option. Okay, so get this. The system was literally designed to blow up if it ever got more than 200 features. It's like a built-in self-destruct button put there on purpose to stop the system from running in some weird, unpredictable, and maybe even dangerous state. So, we've got a system that's been designed to fail under very specific conditions. Now let's get to the smoking gun, the exact piece of code that pulled the trigger, a function in the Rust programming language called unwrap. See, in Rust, when you have an operation that might fail, it doesn't just crash the program. It gives you back this special thing called a result. It's either, okay, here's your data, or error, something went wrong. This is great because it makes the programmer have to think about what to do in both of those cases. But then there's unwrap. It's basically the developer's way of saying, look, I am 100% sure this is going to work, so just give me the value. It's a shortcut. But, and it's a huge but, if you're wrong, if the code runs into an error, the program is designed to panic. And panic is just programmer speak for a very fast, very controlled, very immediate crash. And you can see where this is going, right? For a critical server like Cloudflare, this is a recipe for disaster. One single unexpected error can set off this domino effect, taking the whole service down and basically leaving millions of people staring at a broken internet. Okay, so let's put all the pieces on the table and get to the final verdict. Was this really Rust's fault, like so many people were saying? The truth is, this was a textbook cascading failure. It wasn't just one thing. It was this perfect storm, a chain reaction, really. You had a design choice that put performance above all else, you had this completely unexpected flood of data coming in, and then you had a piece of code, that unwrap, that basically assumed nothing would ever go wrong. You put those three together, and boom, system-wide crash.
And that's exactly why blaming Rust completely misses the point. The sources are really clear on this. The problem was a system-level design choice, a vulnerability in the logic. An error just like this could have easily happened in C, or pretty much any other language for that matter. So, what's the big takeaway here? This whole incident really boils down to a fundamental and I think really interesting question in software design. When things go wrong in a high stakes system, is it better to fail loudly and obviously, or to try and keep running in a broken, unpredictable state? There's no easy answer, but that's the dilemma at the heart of this whole thing.